Hi there, and I welcome you once again to the channel. You see, in today's video, I'm going to be introducing you to the concept of logarithm. We are going to, in this video, do a basic introduction and as well consider the laws of logarithms and solve some questions that will help us in understanding the concept of logarithm. Then in further videos, we are going to solve even more complex questions that are usually asked in exams such as WAEC and JAM. Now, you see, the concept of logarithm is not entirely different from some of the algebraic processes that we've learned before, such as especially of indices. Now, you see, you can even think of logarithm as a special way of viewing indices. You can think of logarithm, I repeat, as a special way of viewing indices. And this is because it is actually a special way of viewing index. You see, logarithm, the principles of indices the principles of logarithm are adapted from those of indices. That is, in a way, we could say that logarithm finds its roots from indices. Now, how do I mean? Let us look at some principles of indices and see how they are related to logarithm. Now, take for example, if I have this expression 3, if I have this expression 3 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3, for example. Now, in indices, remember, how do I abbreviate this expression? Now, to abbreviate this expression, I am going to write one of these numbers because they are the same, they are similar. So I write it as 3. Now, how many 3's do I have here? Here I have 1, 2, 3, 4, and 5. So I have 5 3's. That is 3's appearing 5 times. So I have 3 to the exponent of 5. Now 3 to the exponent of 5 will give us 2 by 3, 3 by 3, 9. 3 by 3, 27. 27 by 3, 81. 81 by 3, 243. So we have this is equal to 243. Alright, so now, how do I write this in logarithmic form? I'm going to explain, but listen, look at what I'm going to do. Now, in logarithmic form, I basically will write log, now, because log is the shorter form of logarithm. The log is the way we shorten logarithm, since it's sweet item. Now, log of 243 base 3 is equal to 5. Now, how is this any related to this? Let me explain how. You see, our answer here is what is actually here, which in this place is the index. You remember in our indices video, by the way, if you have not seen that video, I will enjoy you to go and see the video. I explicated in indices thoroughly. Now, this guy is the base, and this guy is the result, or we said it's also called the power, but now we now use the power for the index. We call it index the power, or we call this guy exponent, index or exponent, or as we call it now, power. Now, you see, how is this now related to this? We have that the log, now the way this is read as so, we have log of 243 to the base of 3 is equal to 5. Log of 243 to the base of 3 is equal to 5. Or you say the log to the base of 3 of 243 is equal to 5. Now, in fact, it is more correct to say that log to the base of 3 because the principal thing is this base, because the base determines whatever will happen here. Alright, now so we say log to the base of 3 of 243 is equal to 5. What does that tell us? It means that here this is saying that I raised this base 3 to the index or to the exponent of 5 and gave me 243. Now, in this case, it is saying that logarithm means that what number will I raise a particular base to give me a particular number. So when I say the log of 243, you simply ask me the base. Then I tell you it is the base of 3. Then you tell me what number I will raise that 3 to to give me 243, and that becomes our answer. So that is what logarithm is. So logarithm is saying that what the log of a number is basically log of a number at a particular base is basically what number I will raise that base to give me that number I'm looking for. Okay, so we could write this as, say, the log of a base x is equal to m, for example, means that it is m that I will raise x to give me a. Simple and short. Alright, very quickly, let us consider the laws of logarithm and see how they are related to indices. Now, the laws of logarithm. The laws of logarithm. Now, just as we have in the first law of logarithm. So basically, we have gotten the fact that logarithm is actually looking for the answer. The answer of the logarithm is basically the power that we consider, the power. Alright. So look at this. Keeping that in mind, we have that a raised to the power m multiplied by a to the n is equal to a raised to the power m plus n. Do you remember this indices law? That the multiplication of the base will give us an addition of the power. Okay? Let us adapt that law into our logarithm. We have the first rule of logarithm. It says that the log of a times b, ab means a times b, as you know in algebra, to the base of x is the same as saying the log of a base x plus the log of b base x. Look at what I did. I basically separated this log and base for both expressions of a and b that we're multiplying each other here. So I have log ab to the base of x is equal to log a to the base of x plus log b to the base of x. And that is intuitively correct. How do I mean? If I am saying that what we are looking for in logarithm is basically the power. So it means that if I have said that a to the n multiplied by a to the n is equal to a m plus n, and you know that at the end of the day this will be our answer. So I am technically saying that the multiplication of the numbers, which will be the result, will give me an addition of the power for the particular item, the particular base that I'm raising it to rather. Now let me make more sense of that. I hope I didn't confuse you there. Now listen carefully. If I were to solve, for example, the log of 32 base 2, for example, now this, I can split this apart. This could mean log of 8 times 4, for example. Right? So let's use it in this form. So A standing for, 8 standing for A, and 4 standing for B. Now, I am going to have that the log to the base of 2 will be split for both expressions of 8 and plus log to the base of 2 of 4. Now, does this make sense? I just split this log and base for the expression of A and B, this expression of 8 and 4. Now, what does this mean? It means that what number would I raise 2 to give me 8? What number will I raise 2 to give me 8? So the exponent that will give me, the exponent of 2 that will give me 8 is actually 3. Meaning that 2 times 2 times 2 is what? 8. So 2 raised to the power 3 is 8. So it means that I will raise 2 to 3 to give me 8. So this is basically 3. Plus, what will I raise 2 to give me 4? And that will be 2 times 2, that is 2 raised to the power of 2. And we have 2 here. So my answer is technically 5 here. Now I'm going to prove this 5 using another law of logarithm. But for now, just take this for the answer, understanding how I explained it. Now what will I raise this 2 to give me 3? What will I raise 2 to give me 4 will be 2. Now when you add this, you're going to get 5. I'm going to solve this expression, the log of 32 base 2, and get 5 using another rule of logarithm, and that information will stick well. Now listen. The second law of logarithm is basically the direct opposite of this, that is more technically and intuitively correct, that says that the log of A over B Let me write that again. The log of a over b to the base of x is equal to the log of a base x minus the log of b base x. So technically, multiplication gives the addition of powers. You know, these answers are powers. Do you understand that? Now, these answers are powers. This log of b base x is a power. As in the answer we are looking for, that this will give us, the expression that this represents, connotes, is a power. So it's going to be a subtraction of the powers. That is the addition of division of bases. Now, what? Look at the third. Now that this will also be proven with a similar operation as I did the other time. Now watch. Look at the third fundamental law of logarithm. The third fundamental law says that if I have something like this, log a to the power b to the base of x, log to the base of x of a raised to b. This expression says that it should become, the law of logarithm says that it should become b brought to the back multiplied by the log that we had, the log to the base of x of a. What is this saying? That this b has crossed to the back of this log. And how is this even correct? How does this make sense? Now, let us make sense of this. Let me use the expression we used the other time. Do you remember we did log of 32 to the base of 2? Now, how can we rewrite this expression, 32? 32 is basically log of 2 raised to the power 5, right? 32 is basically 2 raised to the power 5, right? Of 2. Does that make sense? Now, what does this mean? This means that 5 is going to cross to the back, yeah? And that becomes our answer. But I'll tell you how it becomes our answer in a further law. But let me explain this law in another way. Look at this law. If I were to give you something like this, the log of, good, let us use the same expression. Log of a base x plus log of a base x plus the log of a base x. Now, what does this expression mean? I'm going to get back to this in a minute. But watch. Look at this expression. Now, log of a base x, log of a base x, they are the same, right? So, in mathematics, I could decide to represent them by delta. For example, let's say this thing is delta plus delta plus delta. Because they are the same, right? So what does this mean in algebra? This will become what? 3 delta. Isn't it? Right? So I have 3 delta. How? Because of these are the same. What did I do? I simply said 1 plus 1 plus 1 and it gave me 3 delta. Alright, the same way I could say that this expression log to the base of x of a that is appearing thrice is going to be log 3 times of this thing. That's what it means. 3 times of log a to the base of x. Now, please hold on a minute. Now remember that the first principle says that the log of a plus b, so the log of a base x plus the log of b base x means that these two are actually technically multiplying each other. If we reverse this one, we'll go to the back. Alright, so if this is equal to this, then it technically means that these came from the log of a times a times a. Does that make sense? Alright? To the base of x. So this technically becomes log of a to the power 3 and x to the base of x. Alright? So you see we have come back to this now. Now, using this principle means that 3 can basically go to the back. When 3 goes to the back, we have the log, we have 3 log a base x. And what does this become? It becomes this technically. So you see that these principles are very, very related. And they do not in any way contradict one another. Alright, let's establish a fourth law of indices. Now, there is a law that says that the log of a base x is equal to the log of a over log of x to a convenient base. For example, I change the bases to be in base B. So you see, that is the law of change of base in logarithm. I change the base to a convenient base. You can use any base that you want. In further, I'm not going to be proving this in another video to show you that it's actually correct to use any base you want. You can change it, you can alter the base to anything that you want, any base you want, but it must be similar, number one, and it's going to give you the same answer. I promise you that. Now watch. This is a law that we are going to be using to prove another law. So let's take the fifth law of logarithm. The fifth law of logarithms goes like this. The log, remember the law of indices that says that a to the 1 is equal to what? A, right? So we are going to be using this law. Alright? So the log to the base of a, log of a base a is equal to 1. That's what the law says. Now what does that mean? Let's express it in this form. You can do it any way you want, but if I were to express it in this form, it is telling me that it is going to be log of a over log of b. Now this log of a over log of b, this is equal to this, so this cancels this in simple algebra. Alright? Now, what is it saying is that what power will I raise a to give me a? Technically 1. Alright. I hope you are following me. Now, the one other rule that I'm going to take as the last rule of logarithm, the number 6th rule, is going to be let us manipulate some. Okay. What if you were to have something here, something like this? We have the log of a base x. Now this power, if it were to be on x, what would be our result? Now the result will be equal to 1 over b log a base x. Now let me explain what that is. The 1 over b log a base x. Now how is this possible? Let us go back to this principle. It's very, very handy, you know. Now we have log of a is going to be over log to a convenient base. Now let's repeat the base of n, for example. Now log of x base n, but x, remember, is to the power of b. Now what does this mean? This becomes log to the base of n of a over b log of x to the base of n. Where did this come from? This came from this. This goes to the back. So this has gone to the back, right? So it means that I could rewrite this expression by having, if I remove the base that I introduced, this will become 1. Remember that this was just power 1 and 1 is technically behind it, the coefficient. So we have 1 over b log, this becomes our base back, x of a. So that is where this expression stems from. Now, let us look at the application of some of these laws to see how useful they actually are. Now, let me solve my first question. I have a list of questions here. My first question says that, number 1, says the log of 81 base 3. Good. Now, listen. The way we solve this question, there are 2 approaches that we can use to solve this question. The first approach is to say that this log of 81 base 3 is equal to what? Is equal to x. Now, there was something I didn't show you the other time. Now, okay, I did show you when I said that the log of a to the base of x is equal to m. It's telling us that x is raised to m to give me a. How does that mean? This guy comes, how did this form? What you are seeing here is that this guy comes here and pushes this thing off. Now that is not the technical explanation. I'm just using it to know, for you to know how it came about. This guy comes here and looks like he pushes this guy up and is equal to this guy. So look at the direction we are going anti-clockwise. So what? We're going to do the same thing here. Now there's another approach, but let us use this approach first so that you see how it works for, because this approach is very useful in expanded quadratic algebraic processes using logarithm. So what? this guy is going to come here and push this guy up, and it's going to be equal to this guy, so that we have 3 to the power x is equal to 81. Did you see that? 3 to the power x is equal to 81. And how can we solve this in indices? We are going to make the bases equivalent, alright? So that we have 3 to the x is equal to 3 to what power? 3 to what power will give us 81? I think that is 4. Yes, that is 4. So since 3 is equal to 3, definitely x must be equal to 4. Now, sometimes you are seeing in your textbook that this is cancelled. It doesn't mean that we are dividing both sides by 3. You are not. You are only saying that since this base is equivalent to this base, definitely this power must be equivalent to this power, and that becomes our answer. Now, there is a second way we can go about this question. The second way is, see what we were given, the log to the base of 3 of 81. Now, this becomes, we are going to be using this rule. Since we already know that 81 is 3 to the power of 4, so we say that log of 3 raised to the power of 4 to the base of 3. So technically, we are going to say that since it is the power here, b goes to the back, as we have it here, 4 definitely will go to the back, and we have 4 log 3 base 3. Now, we now have a base that is similar to the result. So see, this log applies. So log a base a, this becomes 1. So this becomes 4 times 1, and that's what? Technically 4. Alright, let's go on to the number 2 question. The number 2 question says that log to the base of 9 or 1 over 3. Alright. Now we're going to apply this same principle to solve this question. And what does that say? We say that this log is equal to what? We don't know. It's equal to x. Alright. So what does that mean? This guy will come here, push this guy up, will be equal to this guy. So we have 9 to the x power is equal to 1 over 3. Now remember that a reciprocal fraction is equal to 3 to the power 1. Well, depending on the power that this guy is raised to anyway, the denominator is raised to. So this becomes this. If you already divide the log with the 1 over equal to a raised by minus 1. Okay. So here we're going to have what now? We're going to have 9 to the x is equal to 3 raised by minus 1. Now, if you would ask yourself, we are going to now use this principle of converting both to the same basis. And this becomes 3 raised to the power 2 will give us 9, right? Then it meets a base here, which is x equal to 3 raised to the power minus 1. Technically, since 3 is equivalent to 3 is equal to 3, then this power must be equivalent. 2 times x is 2x is equal to minus 1. And definitely, dividing both sides by 2, x becomes minus 1 over 2. Alright. Now let us use another principle to solve the same question. If we use the second method we had log is by 1 over 3 to the base of 9. Now, what does this become? You remember that this will become log, the same principle, this becomes 3 raised to the power minus 1 to the base of 9. I've not changed anything. I just made this reciprocal fraction become raised to the power minus 1, an inverse power. So what do we have now? We have that this has turned into this, and we can use this principle, we can adopt that principle. This becomes negative log, that is minus 1 times this, of 3 base 9. Then we can use this principle, we can use this principle, so that we can use any convenient base. Now, intuitively, it is just right to use base 3. Why? Because these guys are in the family of 3. So we can technically say that this is minus log of 3 base 3 all over log of, remember that the minus is upstairs there. So log of 9 is 3. Now, what does this become? You know that all of these become 1, right? Log 3 base 3. But because there's a minus, it's going to be a minus. Remember, log 5 there, rule 5 there. So this becomes minus 1 over, remember this is going to be over log of 3 squared over 3. So technically, we're going to have this to go to the back just as we had here. Is equal to minus 1 over 2 log 3 base 3 equal to 1. So 2 times 1 is equal to 1, and that becomes our answer. Alright, further questions I'm going to solve now, I will not be using both principles. I'll be using only one here because of time. Alright, let's see some other questions in which you can apply these rules of indices. Now, there is one type of logarithm that is known as the natural log. I think I have a question here that deals with that. Look at this question. It says lean, that's question 3. It says lean x is equal to 7. Now, number 1, notice that this is not log, this is lean. Lean means natural log. Now, what is natural logarithm? Natural logarithm means a logarithm with a fixed base, which is the fixed base is the base of e, exponential. Exponential stands for e stands for a particular number in mathematics. I think 2.167. It's a constant. Thank you. It's a constant. All right. So natural log means the log is in base e. That's the meaning. So we can rewrite this expression as log to the base of e is of log base e of x is equal to 7. Alright, so what does this mean? This means that e will come and push this guy up and will be equal to this guy. The same principle. So e to the power 7 is equal to x. Alright, so x is equal to e raised to the power 7, and e raised to the power 7 will give us something around 1096.6. I wrote the answer here actually. When you punch that in your calculator, e raised to the power 7 will give us this. Alright, let's solve one more question. Another question says that the log of x base 9 is equal to 1.5. Okay, so what does this mean? Alright, we're going to apply the same principle. This guy comes in, pushes this guy up. We have 9 raised to the power 1.5 is equal to x. So x will be equal to, remember that 1.5 means 1 over 1 over 2. 0.5 is 1 over 2, so 1 over 1 over 2. And that becomes 9 equal to, convert that to improper fraction. 1 over 1 over 2 becomes 3 over 2. So you have 9 raised to the power 3 over 2. Alright, write the law of logarithm. If I have root of a means a raised to the power 1 over 2. So this thing basically means the square root, but we don't put square root because this thing technically means square root. Then all times 1. This power 1 is there. So, but it's not used, it's not put there because 1 doesn't change it, alright? So here, this will mean that x is equal to the square root now because this is the denominator to be the root. The denominator turns to root and the numerator turns to power. Or is power 3. This becomes x is equal to square root of 9 is 3 raised to the power 3. And that becomes 3 raised to the power 3 is what? 27. And that becomes our answer. Alright. Let's take maybe 2 more questions and we'll call it a day for this introductory video. Now, if you have gained value so far, which I know, I'm sure you've gained value, please do well to subscribe to the channel. Do not be okay that you just watch the video, you cannot subscribe to the channel. Do well also since you liked the video. Also like it, punch that like button. It won't do you any harm. You understand? Alright, let's go on. I'm going to solve 2 more questions and record it today. There is one question here that is looking so fine. This question says the log number, this log, that is number 5, the log of 9 over 4 base 2 over 3. Now, the same way, we're going to say is equal to x. So, and since it's equal to x, we'll say that this will come and push this guy up and to be equal to this guy. So that we have 2 over 3 all raised by x is equal to 9 over 4. Alright. When you look at this, they do not look alike. This one, the family of 2 is in numerator here, but here it is denominator. So what do? We can, how about we take the reciprocal of one of these cases? We can take the reciprocal of this. If we take the reciprocal of this, this will become 3 over 2, or is by minus x. Is that okay? But I would like to do this, alter this rather than alter this. So if we alter this, this becomes 4 over, this becomes 2 over 3 all raised to power x is equal to 4 over 9 all raised to power minus 1. Does that make sense? Good. Now, what does this become? This tells us that 2 over 3 all raised to power x is now equal to 2. This is the family of 2 and this is the family of 3. So 2 over 3 technically. Now, this guy is raised to power 2 to give us 4. This guy is also raised to power 2 to give us 4. Then both of them are raised to power 2. But remember that both of them are also raised to power minus 1. What does it become? It means that 2, let's bring this up here. It means that 2 over 3 all raised to power x is equal to 2 over 3 again all raised to minus 2. This multiplies this. Now you see the way we've been doing it, this is equivalent to this, definitely this must be equivalent to this. So x is equal to minus 2. And that becomes our answer. As simple and short as that. Alright, let's take one more question. This will be our last question in this video. And I'm going to give you 2 questions as an assignment. But you are going to drop the answer in the comment section. So that when you drop it in the comment section, I will know that you actually gain value and were able to do it by yourself. So please do well to drop the answers to the question in the comment section. Let's start with the last question. Number 6 is the log to the base of 3 of 5x plus 1 is equal to 4y. Alright, pardon me, there was an alteration in the video, so I didn't know that the video has stopped. Now, watch this. This is what we have, the expression we have. So we are going to bring this guy to kick this guy up and to be equal to this guy. So this becomes 3 to the power of 4 is equal to 5x plus 1. Alright? And you know that 3 to the power of 4 is 81 is equal to 5x plus 1. So what do we do from here? We will subtract 1 from both sides. If we subtract 1 from here, it becomes 0 here, and we have 5x left here. And this minus this gives us 80 here. So 80 is equal to 5x. Then we can now divide both sides by 5. So x is equal to 16. As simple as that. So this is the last question. And you are going to solve this as the assignment. Now, make sure that you solve this question and drop your answer in the comment section. We have log x base 32. Log of x to the base of 32 is equal to 4 over 5. Or log to the base of 32 of x is equal to 45. Is equal to 4 over 5 rather. Then number 2 says log to the base of 7 is equal to x squared plus 3x plus 9. Let me write this. Log to the base of 7 of x squared plus 3x plus 9 is equal to 2. Right. So you drop your answer in the comment section. Do well to drop your answer and come check them out as soon as I see your comments. Alright, as I said before, I'm going to reiterate that you should please subscribe to the channel, share this video with your friends who might not know who need it. You understand? Share them on your social media platform, Facebook and the rest of them to help this channel. And I pray that as you do so, that God will bless you. In further videos, we are going to solve more complex questions. And until then, keep winning. Thank you.